All right, so now that we've managed to get our program to encode some text, it's time to do the opposite direction, which is how do we get our program to be able to decode a piece of text based on a shift number? So let's say that we try to decode the letter G and we had a shift number of 3. Well, in this case, we actually have to work backwards and shift backwards in the alphabet in order to get the letter that's 3 spaces previously. So in this case, that would be D. Go ahead and head over to Caesar Cipher to start and fork your own copy of it. All right, so we've got all the code that we had at the end of part 1, but now we have to create the decrypt function. And the decrypt function is again going to take the text that the user inputted and the shift number, and both of these are going to go into the function as inputs. And then inside the function, we're going to shift each letter of the text backwards in the alphabet by the shift amount. For example, if we started out with this code and we needed to shift each letter by 5, then we end up with the plain text hello, and finally our function needs to print the decoded text is, depending on what it is that we actually got. Finally, to do part 3, we're going to use that direction variable that we ignored previously, where we ask the user to type encode if they want to encrypt and decode if they want to decrypt. And then we're going to use an if statement here to check which one they chose, and then we're going to call the corresponding function based on that direction. And once you've completed all 3 to-dos, you should be able to run your program and encode a message as well as decode a message when you hit run again. Like that. Have a think about how you might tackle each of the 3 to-dos and then pause the video and give it a go. All right, so how did that go? The first part should be quite easy. All we have to do is define a new function called decrypt, and this decrypt is going to take the same inputs as our encrypt, which is the text and the shift that the user entered. But again, I'm going to use some different parameter names to be able to differentiate the arguments and the parameter. So in this case, because the text that I'm getting is going to be scrambled, I'm going to call the first parameter ciphertext. And the second parameter, I'll call it again the shift amount. Now, after a colon, I'm done with to-do 1. Now let's move on to to-do 2. So here, I have to be inside the decrypt function, so indented inside the function. And then I'm going to shift each letter of the ciphertext backwards in the alphabet by the shift amount and then print out the decrypted text. To do that, I'm again going to need a for loop, and I'm going to loop through each letter in the ciphertext. And for each of those letters, what I want to do is I want to get hold of the position that they are in the alphabet. So I'm going to check the alphabet and then use again that index function and then tap into the position of the letter. Once I've got the position, I'm going to define the new position, which is going to be the current position. Now, remember, we're moving backwards in the alphabet now, so I'm going to subtract the shift amount from the position. Once that's done, I can define a blank variable called plain text, which is just going to be an empty string. And once I've gotten hold of each of the new positions, I can add to that plain text by tapping into the alphabet and then getting hold of the letter at the new position. So now finally, once that for loop's completed, then I can print out the results, and I'm going to use the same sort of output structure as I've got in the example. And we're going to replace that hard-coded text with the plain text that we've decrypted. And finally, I just have to turn this into an F string so that it actually gets inserted. Now, the last thing I have to do is the to-do number 3. So here, we're actually going to check the direction variable. And we're going to see that if it's equal to encode, well, then we're going to call that encrypt method that we had previously, so indented inside the if statement. But else if the direction was actually equal to decode, well, in this case, we're going to call our newly created decrypt function. And we're going to pass in the ciphertext as the text, and the shift amount is going to be equal to the shift. So once again, these arguments come from up here when we ask the user to input those values. And now it should go over to the decrypt function and do everything that's inside to decrypt the text. So now let's give our program a run and just make sure that it works as expected. So I'm going to encode our message hello, shift it by 5, and then I'm going to run it again, and I'm going to try and decode this message now. So I'm going to type decode, and I'm going to paste in that message we had before, and type the same shift number, and now we've got our text decoded. So that's how you solve step 2 of our project. Have a review of the code here, and once you're ready, head over to the next lesson, and we're going to cover part 3 of the Caesar cipher. So for all of that and more, I'll see you on the next lesson. All right, so now that we can encrypt and decrypt our messages, well, you might be asking, well, what else is there? We've completed the project, right? Well, let's think about how we can improve our code. Because if you take a look at the encrypt and the decrypt functions, you'll notice that a lot of the things that they're doing in it are very similar, right? We've got some piece of empty string to begin with. We loop through each of the letters in the text that we get passed over, and we get the position from the alphabet, get a new position, and then add the new letter to that empty string. Your challenge in this part of the Caesar Cipher project is to combine the encrypt and decrypt functions into a single function called Caesar. And we're going to get rid of these if and elif statements, and we're going to get rid of 2 functions that are overlapping, and instead we're just going to have a single function, and we're going to call it just once, passing over text, shift, and direction. So it's going to have 3 inputs, and it's going to save us a lot of repetition in our code. Have a think about what you learned about functions with inputs and see if you can complete this challenge. So pause the video now and give it a go. All right, so let's first create our new function, and we're going to call it Caesar. This function is going to take 3 inputs this time. Not only is it going to get the text, the shift, but it's also going to get the direction. So I'm going to call the first parameter start text, because we could be passed the plain text or the ciphertext. So let's just set it as the start text. The next one I'm going to call the same, so I'm going to call it shift amount. And then the last one, which is the direction. In order to differentiate it from this direction, I'm going to make it a little bit longer. So I'm going to call it the cipher direction. And now, after a colon, we're done with defining our function, and we can start figuring out how we can combine these 2 functions together. We know in both of them we need some sort of way of storing a piece of text which starts out as empty and then ends up being the entire encrypted or decrypted text. Let's create a new variable called end text to contrast with our start text, and we started out as an empty string. Now the next thing we have to do is identical. We have to loop through this text that we get passed over. So let's create a for loop for each letter in the start text. We're going to do something with each of those letters. Namely, we're going to get hold of the position of the letter in the alphabet. So this line of code is actually identical across the 2 functions. Position equals alphabet, using the index function to get hold of the index of the letter that we're currently looping through. The next part is a little bit tricky, because on one hand, when we're encrypting text, we're shifting that position upwards by adding the shift amount. But on the other hand, when we're decrypting, we're subtracting the shift amount from the position. So one way of doing this is, of course, by using an if statement. So you could check if the cipher direction was equal to encode. Well, then in this case, the new position is going to be equal to position plus the shift amount, and then you could do the else statement. But there's actually an even easier way of doing this. We can just check for if the cipher direction was decode, and in this case, we take the shift amount and we multiply it by -1. So remember, this line of code is exactly the same as this, but it's just way more succinct. And now, outside the if statement, we can define our new position and set it to equal the previous position plus the shift amount. And the reason why this works is because let's say that we had a shift amount of 5 and we wanted to encode our text. Well, the new position is obviously going to be previous position plus 5. Now, on the other hand, if we were decoding, well, this if statement is going to trip, and our 5 multiplied by -1 becomes -5. So now when we add -5 to the previous position, so let's say the previous position was 12 plus -5, then a quick check with the calculator should get you 7. It's exactly the same as subtraction. So now that we've gotten over that hurdle, all we have to do is to tap into our end text and to add to it by getting hold of the letter at the new position in the alphabet. And finally, once all of that's done, we of course need to print the results. Notice how previously we said the encoded text is and the decoded text is. Well, let's copy this string and paste it in here. How can we change this part to be dynamic? So depending on the cipher direction. And then this part is easy because we can just replace it with the end text. So one way is, remember that when the user is typing in the direction, they're typing in either encode or decode. So we can delete everything other than that D and then dynamically insert the cipher direction that we get passed. And now if we make that an F string, it should be able to insert encoded text is, whatever the end text is, or decoded text is, whatever it may be. Now we can go ahead and delete both of these functions and also this if statement, and we can tackle to do number 2, and we can simply just call the Caesar function, passing over the start text as the text the user inputted, the shift amount as the shift that they inputted, and finally the cipher direction as the direction that they inputted. Now we've cut down our code by a lot and we've gotten rid of all the repeated bits of code, and we've used what we've learned about functions with inputs to vastly simplify our code. We're getting the same function to do repeated actions, but depending on the different inputs, it does something completely different. So now let's give our code a run and let's just make sure that everything works. Encoding. And decoding. Brilliant. So did you manage to get that right? Don't worry if you used a slightly different way of coding this logic up. It really doesn't matter as long as you manage to get it to work in the end and combine the two functions into one. Once you're happy with step 3, head over to the next lesson and we'll tackle the final part, part 4 of the Caesar cipher, where we complete our project. For all of that and more, I'll see you on the next lesson. All right, we're about to cross the finish line. We're on to the last part of our Caesar cipher, and we're going to complete it in this lesson. First, go ahead and fork your own copy of part 4 of the Caesar Cipher starting code. And notice, firstly, we've got an extra file here called art. And this, if you expand it fully, you should see an ASCII art of our logo. Now, what we want to be able to do in this lesson is just to tidy up some of the loose ends, improve the user experience, and fix some of the bugs that you may or may not be aware of. To do number 1 tells us to import and print the logo from art.py, and this is going to show up when we first load up our program, like this. Next, we're going to tackle this one. One of the things we haven't really thought about is if the user enters a shift number that's actually really, really large, like 100, then we're actually going to run out of letters in our alphabet. And so we're going to use what you've learned before, and it might take a little bit of thinking around this to fix this particular bug right here. And once you've done that, then we move on to over here and we think about what to do if the user wanted to type a number, a symbol, or a space. So we want to preserve the symbol, space, or number that they typed in. And we're only going to use our cipher on the rest of the message. So only the alphabetical letters. And everything else we're going to leave the same. So for example, if we had the text, meet me at 3, then the end text will keep the spaces where they were, keep the numbers where they were, and also if there were any symbols, we would also keep that in our final end text. And it's only the letters which will get scrambled. And then finally, to do number 4, we're going to figure out how to ask the user if they want to restart the Cipher program. So notice how in the final version, when we've run this once, we can actually type yes to go again. This way we can keep encoding and decoding as much as we want until we're actually done, when we can type no and it says goodbye, and that's the end of the code. What we want to be able to do is, instead of having to run our code again and again, we're going to figure out a way of getting our code to be rerun if the user typed yes to this question. And if they typed no, then and only then do we actually end the program. It might take a little bit of thinking to figure out how to solve all of these to-dos, but once you're ready and if you're up for the challenge, then pause the video now and give it a go. Alright, so let's tackle them one by one. The first one you've already done before. All it needs is to import the art file. And if we want to be able to use the logo variable inside the art file, this one, then we can also simply just write from art import logo. So now we can print this logo right here. So that's to-do number 1 completed. Now let's do the next one. This one requires us to figure out some sort of clever solution so that when a user enters a shift that's greater than the number of letters in the alphabet, over here, we have some sort of way of getting it back within the range of 0 to 25. And I want you to see what happens when I type a message and I put a shift that's really large. You can see we get an index out of range error because there is no letter at position 77 from the alphabet. So that's why this line 14 over here actually breaks down. If you had trouble with this, I gave you a hint where I wanted you to think about how you can use the modulus. Say if we said 45 divided by 25, then it would give us the remainder. So 25 goes into 45 once, and then we have a remainder of 20. So that is what this would equal. 45 modulus 25 would actually give us the output of 20. Effectively, what I'm asking you to do is, even if a user gave us a number that's too large, say 45, we're going to subtract 25 from it, or as many 25s as we need, so that we get it within the range of 0 to 25. And the code that achieves this is simply changing the shift from the one that the user inputted into a version where we use the modulus. Now, if we run our code again, then you can see that no matter how long my shift is, I'm going to use 87, we end up with the result. It's like as if we took 87 and we divided it by 25, and we can see that there's 3 25s in 87. 87 minus 75 gives us 12. And that means the shift is equal to 12. If this is at all confusing, I really recommend to print out what shift was equal to before we did this manipulation, and then to print it out after we've done that. And this way you can see how we're actually manipulating that shift number so that we end up with a shift that fits in to that range between 0 to 25 so that our code doesn't actually break. And once you're done, let's move on to do number 3. So here we want to be able to allow any number, symbol, or space, basically anything that's not within the alphabet, to go through and end up in the end text. But if it is one of the letters inside this list alphabet, then and only then do we actually want to do the shifting and encoding. In order to achieve this, we should probably use an if statement to say if the character. So notice how I've changed the for loop to, instead of writing for letter in start text, which kind of assumes that everything in the start text is a letter, to char, which stands for character instead. Because a character could be a number, could be a symbol, could be a letter, could be space. And then once we get hold of the char or the character, we're going to check to see if the char is in the alphabet. So if it is indeed one of these letters and not some other random character, well then and only then do we actually want this code to be executed. So let me just make sure all the indentation is correct. And if it's not inside the alphabet, so else, well then in this case we actually want to make the end text append the actual character, so without any modification. Now if we test this code by running it, so let's go ahead and encode, and I'm going to encode something like hello 1 2 3, some symbols, a space, 3 2 1, and now when I hit enter and I give it a shift, then you can see that the encoded result has all the letters, all the things that are in that list, the alphabet, encoded. But everything else, the numbers and the symbols, are all left as they are. Because more often than not, your user might want to write a message like meet me at 5 or something something exclamation mark. And this is just a very simple way of making it work. Now, of course, there's a lot of other ways that you could have solved this. So you could have, in fact, added a whole bunch of symbols and numbers and space and other characters to this list. And instead of calling it alphabet, it could have been the characters list. And then you could have encoded all of that. But that's actually not what the to-do asks for. It wants us to let through the numbers, symbols, space, and only encode the letters. So now all we have left is the last to do. And this is probably going to be the most difficult one out of the lot. What we want to do here is we want to be able to ask the user whether if they want to go again. So whether if they want to encode or decode another message. And what happens in the final version, the completed version of the app, is if we encode a message and we get the result back, it doesn't just end, it doesn't exit, because otherwise you would see that message down here, run again. Instead, it continues and it asks us, well, do you want to go again? So we could write yes, and it lets us again encode or decode a message. We can basically go on and on and on and repeating this program until we want to exit. And it's at that point when we can no longer type anything into our program and our code ends, and we'd have to run the whole thing again in order to use it again. So at the moment, the part of our code that actually needs to be repeated if the user wanted to restart it is actually just this part. So the first thing I'm going to do is I'm actually going to shrink it down a bit. So where we've got all this print code from previously, where we were trying to figure out how this worked, I'm going to get rid of that. And now all we're left with is 1, 2, 3, 4, 5 lines of code, which needs to repeat if we're going to get the user to reuse the Caesar cipher. What if we go ahead and indent this and put it inside a while loop? What are we going to check to make sure that our loop continues? Well, we could create a flag called should continue. And we start this out to be true. And then while this is still true, we continue to keep looping through this so that the user gets to input a new direction, new text, new shift, and call the Caesar cipher on that again. When should we stop it though? Well, if at the end of deciphering or encoding their message, we ask them a question, something like type yes if you want to go again, or type no if you don't want to, we could put that inside an input, like so. And we can save their answer inside a variable. Let's just call that result. So now we can use an if statement to check, well, if the result is equal to no, so when they actually want to stop and they want to exit the while loop, well, at this point, we can switch that should continue to false. And once that's done, then this means that this while loop, when it checks it, this is going to be false and it will no longer continue. Just as a final touch, we can even tell the user goodbye, so that they know that the program has ended. Now let's go ahead and run our code and see if it works. All right, so let's first encode something. And now I can type yes to go again. And you can see it's allowing me to type encode or decode. So let's encode something else. Now, finally, if I decided I've had enough, I'm done with encoding and decoding, I'm going to type no, it tells me goodbye, and I can now see my prompt, which means it's actually exited out of the program, and I would need to run it again in order to restart it. Did you manage to get that right? If you want to take a look at the completed code, then you can head over to Caesar Cipher for End and you will find the same code as I've got here. And of course, feel free to play around with the code, modify it, and make this program your own. So if you wanted to add some extra features, if you wanted to make sure that the numbers and symbols are all being encrypted, add any sort of bells and whistles and anything else that you can think of, this is the time to do it now. But once you're done, be sure to get some rest because tomorrow is yet another packed session where we're going to talk more about Python dictionaries. For all of that and more, I bid you good night and I'll see you tomorrow. Hey, well done for completing day 8. Now, somewhere along this journey, you will feel a dip in your motivation. It might happen around now, it might happen later. But what you got to think about is what really motivates you. Why are you doing this? What is learning this skill going to do for you? What is it going to do for your family? It might be that you want to get a better paying job. It might be that you just hate your current job and you want to do something that you actually enjoy, like programming. Or maybe you want to start your own business and you need the skills to be able to build the product that you're going to sell. So have a think about what drives you, why you're doing this. Write it down on a piece of paper, put it up on a wall so that you can see it every day when you wake up. And maybe comment in the box below so that other people can cheer you on and you can be motivated and also motivate others. So have a think about that and I'll see you tomorrow.